In this video, I'm going to take you through the 3.3b lesson, lines of best fit. Most real-world data does not fall perfectly on a line. However, if the data on a scatter plot resembles a line, we can fit a line to the data, write an equation for the line like we did in the beginning of Module 3, and use the equation to solve problems and make predictions. The line that you use to represent the data is called the line of best fit. We will refer to the equation you write for the line of best fit as the prediction equation. The most common way to find the line of best fit is to draw a straight line through the center of a group of data points plotted on a scatter plot, having some points above the line and some below. Examine the scatter plot to complete the following. We're going to state the association like we did in the 3.3a lesson. So looking at the data here, this is going up, so it's positive. It looks very linear. It's not as ambiguous as maybe some of the other ones from 3.3a. And it is, I would say, not perfect, but quite strong. So we will describe it as a positive, strong, linear association. Next, we're going to draw in the line of best fit. And it does not need to pass through any of the points. It just needs to be sort of the average of the points and go through the middle. It does not need to hit the first point or the last point. So on this first one, I'm going to draw in a line that looks like goes through the middle of this, something like this. And it just so happens that it does look like it's probably going to go through this first data point. And once I drew this, because I drew it on my tablet, I would probably want this down just slightly. It kind of moved the stylus up just a little bit. So if I could draw this on a piece of paper, I probably would move it down to here. But for the purpose of this, that's close enough. Then we're going to pick some data points that are not necessarily the plotted scatter plot points, but points on my line to estimate the slope in the y-intercept. So that point, and maybe that point, and maybe that point, and maybe that point. So looking at my change in y over change in x, or rise over run, and also incorporating the scale of this graph. So when it goes up 1, it's actually going right 4 units. So I'm going to say that the slope is about a quarter. It seems to work for the most part. And I'm going to say that my y-intercept is at 0,1. So that means that our prediction equation is that y, and we're going to put approximately equals 1/4 x plus 1. And this will vary a little bit when you do your own, in that you might not have the same exact equation, but it should be, for the purpose of this problem, a slope between 0 and 1, a fraction, and a y-intercept that's pretty close to 1. All right, next, it states we're going to use this to find the value of y when x is 10. So we're going to plug in 10. And do some number crunching. And we get that, and it also says to write it as ordered pair, that the matching y value for an x value of 10 is about 3.5. If you chose a different m or b, then you'll notice that your approximated y value will also be slightly different. We'll do the same thing. This time they want us to find x when y is 5 1/2. So this time we're going to solve. And we get 18. And so the ordered pair for this would be 18, 5.5. And if we go back up to our graph and analyze these points, 18, 5.5 looks pretty close with our line of best fit and with the data set. And it asks us, does this check out? And we'll put yes. The scatter plot supports these answers.